What follows here is an outline of null hypothesis significance testing. You shouldn't think of this as the formal procedure, but we're going to start talking about the different pieces of significance testing or hypothesis testing, however you want to call it. And we'll dive into much later how to actually carry out a specific hypothesis test, depending on what parameter we're testing, what other conditions are true about the samples, etc. But roughly then, we're going to start talking about the different pieces, and then of each piece, we'll delve into much more detail in a later video. So the first thing to think about with hypothesis testing is that we're testing or assessing a claim, okay? So a claim is made about some population parameter, such as a mean, a proportion, a standard deviation, or equality of these proportions and means and standard deviations. So our first thing to do is to formulate our hypotheses. And roughly what we're going to have is we have what we assume to be true, that could be the claim, and then what logically would have to be the opposite case. So if something is what we assume to be true is something like the mean is equal to 10, then we would pick the logical opposite, or something that doesn't include that case. So what the alternative, and there may be multiple different versions of this, must be. Okay, and so think of this as a battle of truth between a claim and its opposing claim. The second step, by the way, the hypotheses will be expressed in plain English, and they will be expressed symbolically as well. So the second thing to do is to determine the correct theory-based approach. We call this a theory-based approach because we're fundamentally using the tools from Chapter 6 and Chapter 7 to assess the claim. So whether we're looking at a claim about a proportion, a mean, or some other characteristic, right? So we have maybe proportion, p, mean, mu, standard deviation. This is an example of what happens when we're looking at just one population parameter. And we'll use the underlying sampling distributions to bring in, formally, probability, right? How likely is it that we get a sample statistic? How likely is the sample evidence against what we agree to be true? These methods, these approaches, depend on the underlying conditions, and when we cannot reasonably use those conditions, we'll have to find alternatives, and one of those alternatives might be something that we call a non-parametric method. 3, we determine an agreed upon risk of error. So our agreed upon risk of error means that when we are looking at a claim and determining whether it could be true or not, it's possible to reject something that's true, and it's possible to not reject something that is actually false. So we won't get too into it right now, but we're assessing the likelihood of obtaining sample evidence given that we assume the baseline hypothesis is true. So given an assumption of what is true, what is the maximum allowable risk? When we say risk, think probability of being wrong. And this goes both ways. This cuts both ways in terms of either a false positive or a false negative. But what we ultimately will use here is this risk, and we'll call that the significance level. So more on that in a later video, though. 4, of course, we collect sample evidence. So our sample evidence comes in the form of a random sample. And from that random sample, typically we extract some point estimate, or otherwise some statistic from the random sample. So this point estimate, we're going to assess how strong our evidence is. And it's related to how close our estimate is to the hypothesized parameter value. And we'll, of course, use things such as the sample size and this agreed upon risk of error. 5, we determine how likely or unlikely our sample evidence is. This is where we start to tie things together, right? So for each test, for each testing procedure, we will be using something called a test statistic. This test statistic is going to come from the point estimate and the sample size and the underlying sampling distribution and so on. And we'll evaluate how likely it is that we got that value by random chats alone, assuming that we have this claim to be true. So, in other words, how significant is our evidence? And we'll tie that to the agreed upon risk of error, of course. Now, the very last step then, as is common for anything that we do here that is related to assessing and application to our discipline, is to interpret the results. So in other words, once we decide to reject or fail to reject the assumed hypothesis, we'll restate it in terms of the original claim. So we restate the decision based on our evidence and its likelihood in terms of the original claim. We might say formally restate the conclusion of this test, okay? Now, there's always some amount of risk, but by clarifying all this up front, we have a standardized way of assessing all claims of the same nature. So whether it's a claim about a mean or a proportion or about equality of two standard deviations, by following these steps in this order, we'll be able to have a standardized way of dealing with all of them. And of course, that means then that it's quite a bit that we have to talk about. So in the next videos, we'll break these down one by one and talk about all the related terminology and concepts